All right, what are we talking about today? Quadratic inequalities. Okay. Let's see if I can make the screen come on. Okay, there we go, so you can see it. Okay. Quadratic inequalities, well, what is that going to entail? So graphing and shading, right? Graphing and shading. And let's write ourselves some notes in this first little rectangle right here, okay? So if we're graphing, and this is the sign, what are we going to do? We're going to make it a dotted line. Now I'm going to go ahead and put this here because there was some discussion about this last time. Because when I make my dotted lines, I go like this, right? And some people were like, that's dashed, that's not dotted. Dotted would be like this. And I said, shut up. Not rude. No, I was not rude. I was just kidding. But does everybody understand that? Are you going to be okay with if I draw this and then say dotted? Oh my goodness. Less than or equal, greater than or equal. What kind of shape am I going to draw here? Solid line. Okay. How are we going to know where to shade? So we've got all these signs we have to take into account, right? We're going to shade where it's true. What do I mean by that? Substitute a point into the inequality, right? And what do we want to be careful about when we choose our point? We want it to have a 0 in it. That'll make it easier, right? Do we want to choose the origin if we can? Yes. When can we not choose the origin? Or when it passes through the origin, or it's really close, right? Because if it's really close, maybe our graphing was messed up a little bit, and we don't want to get it wrong because our graphing was messed up a little bit. Does that make sense? Okay, so tell me politely what to do. Y is less than or equal to x squared plus 5. Now, I know some of you are thinking to yourself right now, self, I should really use my transformation rules. Didn't you just think that to yourself? Oh, good job. Excellent. Okay, so how am I going to graph this then? Up 5. And that is my vertex, right? That's my vertex. Okay. Which way does it open? Oh, up, because this is positive, right? Is it parent function shaped? Is anything being multiplied or divided by this term right here? So it is parent function shape, right? So from my vertex, I can go over 1, up 1. I can go over 2, up 4, because 2 squared is 4. Oops. 1, 2, 3, 4. And I could go over 3, up 9, right? So let's see, over 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I know parabolas are symmetric, so I could just mirror the points on the other side, right? Okay, keep telling me what to do. Oh, solid line. Why is it a solid line? Or equal to, right? That's the clue to tell you one way or the other. Okay? And now all that's left to do is shade. If I choose 0, 0, 0 is less than or equal to 5. Yes, that's true, right? So wherever that point is and it's true, I shade there. Done. Again, please don't get all OCD on me and have to color every single square right here. You can do it. And that's done, isn't it? Good. Any questions? Okay, let's try another one. Y is greater than x plus 2 squared minus 6. Now, if it's in vertex form, this is super cinchy, isn't it? Where's my vertex? -2. -2, -6, right? Is it parent function shape? Because is there anything being multiplied by it in the front? So it is parent function shape. And it opens up or down? Up because why? It's positive, right? So over 1, up 1. Over 2, up. From the vertex, right? Not from the origin, but from the vertex. Over 3, up 9. And over 4, 16, right? Because 4 squared would be 16. Now here I didn't go over 4 up 16. Why not? Yeah, there's not enough room, right? There's room here, so go ahead and do it. Okay, somebody different who hasn't spoken yet. Tell me what to do next. A dotted line. Why is it a dotted line? Okay, it's just greater than, not greater than or equal to. Somebody who hasn't had a turn yet, tell me what to do next. We need a shade, don't we? Okay. Can I choose 0, 0? It's super close, right? I don't want to get it wrong just because my graph is wrong. So let's choose another point, but let's choose a smart point. So we want to choose a point on the axes, right? Because at least one of those values is going to be 0, right? Why would this be the best point to choose? -2, 0. If I put a -2 in for x, what does this become? Oh my gosh, I'm so smart. So are you. So 0, and then y is already a 0 because it's on that axis, right? So 0 is greater than -6. True. Shade where the true part is. This time it's on the inside. Any questions? You ready for another example? Okay. Uh-oh. What does that mean? Oh, there's 2, right? Do I need to use this graph and this graph down here? Oh, okay, so it's a system, so I have to graph it on the same graph, right? Okay. So I'm going to graph this first one in green, if that's right with you. I'm going to graph the second one in purple. I almost chose red, but I don't want anybody to think I'm celebrating Christmas too early. So, okay, so how do we graph this first quadratic inequality? Start at the origin. Because vertex form-wise, there's nothing being added or subtracted to the x, and there's nothing being added or subtracted to the end, so I know my vertex is at the origin, right? Tell me what you know about this quadratic. So it's not parent function shape, is it? Okay, what else do you know about it? It's opening down. So this time I'm going to go over 1 and down 5. Normally I'd go over 2 and down 4, but I'd have to go over 2 and down 20, because 4 times 5 is 20, right? But I can't do that. So really, these are the only 2 points I have, right? Pardon? No. From this point? Oh, we never do anything from this point. We always do everything from the origin. Over 1 down 5, because 1 squared is 1, but it's times 5. I would go over 2 down 4, because 2 squared is 4, but 4 times 5 is 20. So from the origin, I'd go over 2 down 20. Okay? Tell me what to do now. dotted line. Do I want to shade yet? Do I want to tell myself where to shade? Yes, okay. What am I going to tell myself? Can I choose the origin? No. How about if I choose a y value of 0? Would that be easy? So, where's the y value 0? Oh, on the x-axis. Okay, so maybe like this one. Is that okay? 2, 0. 2 squared is 4 times negative 5. 0 is greater than negative 20. Okay, so where am I going to shade? Outside. So is it okay if I just draw myself some little arrows like this? Like that? Okay. Now the purple one. Okay, how am I going to graph the purple one? Top. Is anything being added to or subtracted to the x itself? No, so I'm not going left or right any. Where am I going? Down 2. From this point, where do I go? Does it open up or down? And isn't parent function shape? No, because I've got the multiplier of a 3. So instead of going over 1 up 3, I'm going to go over 1. Instead of going over 1 up 1, I'm going to go over 1 up 3. And instead of going over 2 up 4, I'm going to go over 2 up 12, right? It was 4. 4 times 3 is 12. So over 2 up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Normally I'd go over 3 and up 9, but this time I'd have to go over 3 and up 27. I don't have enough room for that, do I? Okay. Tell me what to do. Dotted. Can I choose the origin this time to figure out where to shade? Yeah. 0 is greater than negative 2. Okay. So I would shade where the origin is, which is inside the parabola, right? So where am I going to end up shading? So inside the purple one, but not including the green one, right? So like that. Yeah? So if we're solving by graphing, especially inequalities like this where it's y, where y is associated with it, or a system of inequalities, do you have any questions about this? Is this good? Confident? Okay. Your direction seemed confident, so I'm going off the fact that you seemed confident when you were talking to me. Is that okay? So what happens when something shows up like this? Are we still graphing this? Well, we will eventually graph it, but will it be on a 2-coordinate axis? Or a 2-axis coordinate system? No, because how many variables are there? Really? There's 1, right? It's only x. Okay, then we only have 1 variable here, so we're going to graph this on a number line. Yeah? So what do I do? How do I solve this? Well, it's a quadratic, and you know 5 different ways to solve quadratics. But we just said we can't do graphing because there's no y. And there's an x squared and an x, so can't do square roots. Why don't you want to do completing the square? Okay, so that leaves 2. Leading coefficient is not 1, so I don't want to do completing the square. What's left? Quadratic formula or factoring. So that's been quite the discussion today. Some people are like, definitely factoring, because they like factoring and they're good at it, and it's usually quicker than quadratic formula, isn't it? And some people don't want to do factoring here because the numbers are already big. right? Is there a right or a wrong answer? No. What do you want to do? See, even here, there's not an agreement, right? So if you want to do factoring, sit and work on it with factoring. If you want to do quadratic formula, sit and work on it for a second with quadratic formula, and let's see what we figure out. Do it. Which way was shorter? This time quadratic formula was shorter, yeah? Now, did you guys see what I did here? I just made these equal signs right here, and I wrote greater than or equal to first, and then I realized I got to stop that because I have to figure out where my answer is. And to figure out where my answer is, I got to figure out my two boundary points, which is negative 3.5 and 1.5. See, over here with quadratic formula, it was just equal, wasn't it? Because I used quadratic formula, which is x equals, right? So I got to figure out what my graph looks like to be able to figure out what my answer is. Negative 3.5 is right here. 1.5 is right here, right? Remember when we did inequalities before, linear inequalities? It was either on one side or the other, right? Well, with quadratics, we've got 2 points. It's either between them or outside of them. Does that make sense? It can either be between them, like greater than negative 3.5 and less than 1.5, or it's less than negative 3.5 or greater than 1.5. Does that make sense? So I have to figure out which one that is. Well, guess what we get to do again? Choose a point. And if one of our points isn't 0, choose a 0. Okay? Go back to the original equation. Plug in 0. 0 plus 0. So negative 21 is greater than or equal to 0. That is false. So I'm going to shade not where the 0 is. Well, what does that mean I'm shading? On the outside, right? I'm shading over here and I'm shading over here. What's happening at my endpoints? They are filled in circles. So how do I write that answer? How is it related to negative 3.5? It is less than or equal to negative 3.5. How is it related to 1.5? Greater than or equal to 1.5. What's the word that goes in between them? Why is it or? You can't have both, right? There can't be a number that's less than negative 3.5 and greater than 1.5, correct? What if I shaded in between them? What would the word be? And more likely we'd write it a different way, right? We'd write it as one inequality instead of two separate inequalities. Okay? Now, do you have to do both of these every time? No. We've done quadratic formula a lot lately. We've done factoring a lot lately. I wanted you to see what it was like compared. Okay? Some people are like, oh, factoring is always shorter. Not this time, right? Not this time it wasn't shorter. This time, quadratic formula is shorter. Is there any way for you to know that before you start doing a problem? No, there's not. Pick a way that you feel confident in and do it. Okay? Just for the record, there are several on your homework where this is like 402. This was nice because 400 has a square root, right? 20. Well, until we got to word problems, right? All before, we just left that as a square root of 402, unless we could simplify it, right? This time, we can't, because that doesn't make sense on a number line. 2 plus or minus the square root of 402 over 6 doesn't make sense on a number line, does it? I need a decimal. So at this point, this is when we start using our calculator. Find the square root of 402, do negative 8 plus it, and negative 8 minus it, and divide it by 8 and see what you get. Those are the numbers that go on your number line. Does that make sense? Do you have any questions about any of that? So for the record, how many decimals do I want you to go to? 3 is always safe, so tenths, hundredths, thousandths, unless it asks for something specific. So if it's just me saying round, I'm almost always going to want you to go to the thousandth, okay? But I'll tell you right now, that's not what you need to do for tonight. That's not what the textbook asks for, okay? I believe the textbook asks for the hundredth. So just read the directions and make sure. If it doesn't say specifically, go to the thousandth, okay? But that's a good question. Any questions about any quadratic inequality stuff? How do you know whether to graph it or whether to solve it algebraically like this? The instructions will help a lot, okay? Since you know sometimes this is multiple choice, you can also look at the answers and see how it wants you to solve it, right? Or most likely, if it's equal to 0 or greater than or less than or 0 or something like that, you're wanting to do algebraically. When there's two variables, you want to solve it on an XY axis. Does that make sense? All right. Peace.